Now we're going to, now that we know the derivative of tan and secant and cotangent and cosecant, and from the other days, sine and cosine, we can use them in all sorts of stuff. Now, what you're going to learn, well, first let's do the first one, and just because it's tan, it's not a big deal. But remember, just like way back when we did the sine and cosine, it's easier to write this as tan x all cubed. It means the same thing. Once it's in a nice notation, then we go off and differentiate. That's going to be a theme for today. So this is a little better notation. So we're going to differentiate this. I see something to the power of 3. So the Russian doll idea, I don't care what that something is. It's something to the power of 3. So it's 3 to the power of, or 3 times the thing to the power of 2, one less exponent. That something in this case is tan x. But then I have to differentiate inside. So the Russian doll, I did the outside, now I'm doing the inside. And the derivative of tan is secant squared, just from what we discovered this morning. That's really it. I mean, we can tidy this up a little bit. We don't need to breathe secant squared out front. It's not going to make it any nicer looking. So I'm just going to leave it like that. So the derivative of this question is just 3 tan squared x secant squared x. But the reason I'm doing this, I'm going to remind you to do the outside and then differentiate the inside. It's just the inside now is some of the new functions. B. Now B, you could go off and use the quotient rule. So feel free if you want to use the quotient rule. Derivative of the top times the bottom minus derivative of the bottom times the top, all over the bottom squared. However, one of the things that I would advise you to do with all of these trig questions is to see if you can make the question easier before you differentiate. So I'm going to do this all in blue. I'm going to try and make this easier. And remember, and we kind of did this already in the proof before, we can make it easier by changing the sines and coses. So the top, the secant is the reciprocal of cosine. Again, I'm getting mad there. And the bottom, cosecant, is the reciprocal of sine. I wish it was the other way around. It's not. But I've expressed it in sine over cos, or sines and coses, excuse me. Next, you'll see that I have a fraction on the top being divided by another fraction. And I remember to divide fractions, I have to multiply by the reciprocal. So the top I'm going to leave as is, but I'm going to multiply by the reciprocal, and the reciprocal of 1 over sine is obviously sine over 1. This multiplication now is a little bit easier. It's 1 times sine on the top, which is just sine x, and cos times 1 on the bottom, which is cos x. So I've made the question when it had secants and cosecants much easier, and now it's sines and cos. And in fact, I can make it even easier because sine over cos is tan. You'll notice that I have not differentiated yet. I haven't found dy by dx. I haven't done the green step here, the dy by dx. All I've done is change the question to make it look easier. And in fact, it's really easy. Now it's just tan x. Well, I can differentiate in one step. The derivative of tan x is dy. The derivative of that is secant squared x. Done. One line. So the calculus is one line. The trigonometry, of course, like a couple of more lines. And if you really wanted, you could go back to the original and use the quotient rule on the original. And after all the simplifying, after you do all that and then do all the simplifying, you would get down to the same answer. But you can see here where it's much easier to make it do the simplifying of the trigonometry before you do the calculus. So in both A and B, I did that. There wasn't much to do in A. I just moved the 3 out. But in B, you could do some work to make the question easier before you differentiate. C and D are just examples where you can start bringing in all the other functions. So here I've got a tan x times an e to the power of x. Hopefully you'll notice that this is two different functions. Tan x is its own function, and we're being multiplying by e to the power of x. So I'm going to use the product rule. And then the catch here is just like the product rule we did way back in the second unit when we were differentiating all sorts of stuff. It's just these products are of the new functions that we've discovered. So there's no simplifying I can do before, so I'm going right to the calculus, right to the green pen, and I'm going to use the product rule. Now I have a tan, so the derivative of tan is secant squared. That's the derivative first. Times the second, which of course is e to the x, just by itself. Then I add the derivative of the second, which is e to the x. I should differentiate the x, but it's just 1, so that might be redundant. So that's the derivative of the second times the first, which in this case is tan x. Not much simplifying I could do, but because this is a question that has an e to the x, I'm guaranteed to have a common denominator, or common factor. So just like last unit, I should simplify this. I've got a common factor of e to the x here and e to the x here. I don't see any other numbers or anything else that's the same, so it's just a simple common factoring. It would leave me with a secant squared x plus 1 tan x. I'm not going to write the 1 down. Tan x. That's it. B, I'm now doing 18 cosecant 1/3 x. Notice that this is just one function. There's no product rule here. It's just one whole function. It's a cosecant function. This 1/3 x is its own function. The 18 is just a coefficient. So it stays out front just like all the other coefficients have. So there's no simplifying I can do. I'm just going to go right to the differentiation. And I'm doing the cosecant of something, or blah. So the derivative of cosecant blah is, well, the derivative of cosecant is cotangent, negative cotangent, excuse me, cosecant. Right? I think I actually have that written down the other way. Should be written the other way. Sorry. It's what's in our notes, so let's stick with that. I don't know why I wrote that down that way. The derivative of cosecant is negative cosecant of whatever, cotangent of whatever. Now that whatever is just, in this case, 1/3 x, right? But remember, anytime I do the derivative of cosecant, it's cosecant blah, then I have to differentiate the blah. So now I got to differentiate 1/3 x. Well, the derivative of 1/3 x is just 1/3. Remember, if this was a 7x, right? 7x, the derivative of 7x is just 7. So it's not 7, it's 1/3. But no big deal, 1/3 x is just 1/3. Now I can do some simplifying. I've got an 18 out front here. I've got a negative, so I'm going to multiply by a negative, and I've got a 1/3. 18 times 1/3 is the same as dividing by 3, so that's -6. And then the rest is all just as I see it, 1/3 x cotangent 1/3 x. So you've seen 4 examples. You've done some proofs. Now you've got some practice. The practice is a worksheet that the supply teacher can give to you now. It looks like this. Derivative of all the other trig functions. You'll notice that there's a summary of the derivatives right at the top. The ones that we did last week or last day 1, and the ones we did today. And then a bunch of questions and the answers are there. If you want to see some of the solutions to the answer, you can go to Moodle. And on Moodle, I do have a couple of selected ones. So here, for example, is 1D from the worksheet, 1G, 1I, and 1K. All of those are there. Oh, I even have 3B. So you can go to Moodle and see all of those. But you've got enough practice here, so you can go to the worksheet and Good luck.